Okay, we're going to start off with probability on page 195. And probability, we would have done probability 1 back in the other book and it was really simple. The start of this is fairly handy. We've done 3 diagrams before. I'm just going to quickly go over that today. The thing about probability questions, which I'll emphasize as we go through this chapter, is sometimes they look quite simple, but it's the subtlety of the way they ask the question that sometimes catches people out. So what I'll see sometimes is that people will come out of an exam thinking that probability, they've got full marks when they've actually gone totally wrong. So there's some subtle things that they say in questions that lead us to go down different paths. But the first one we're going to do is 3 diagrams, and shouldn't be too difficult because we have done it before. So a tree diagram is when you draw out something that looks like a tree. You will have seen it before with its branches, and we use it so we can see all the possible outcomes of more than one event happening. Okay, so usually 2 or 3. I think we usually did 2 in junior cert. We're going to do 2 or 3 in the leaving cert. And this time we're going to introduce when we put the ball back or put the bead back or put something back, or when they're independent of each other, or sometimes when they're not independent of each other. So we'll do 2 quick examples. I'm sure some of you will be able to do this without the examples, but again, it's probably not fresh in your mind. So, first thing, this is the example on page 196, the first example. It says box A contains 3 red, 4 blue. Box B contains 2 red and 3 blue. 1 bead is taken at random from each box. So there's 2 things that are occurring here. 1 from box A, 1 from box B. They are not dependent on each other. No matter what I pick from box A, box B will have the same probability. There's nothing being affected in box B from the selection in box A. So it says, part 1, draw a tree diagram to show all outcomes. So to show all outcomes, first box, I'll do this in black pen. I got my red pen ready as well. Box A. Has 2 outcomes, red and blue. The probability of red in box A is 3 out of 4. So you put that on the branch. And box B, box A still, blue out of 4 is 4 out of, that's wrong. First mistake, 3 out of 7 and 4 out of 7. Okay, rushing. 3 out of 7 and 4 out of 7. Okay, then we move on to box B because that's the second event that's going to happen. So I'm just going to do this, box B, and we draw something like that. Okay, in box B there's also red and blue. So red, red, blue, blue. Now box B is totally independent of box A, so the probability of getting, so this is saying probability of getting a red after getting a red has no, it does not depend on this. Okay, so it's just looking at box B, it's 2 out of 5. And the blue is 3 out of 5. Same here, 2 out of 5, 3 out of 5. So once we've got drawn out our tree diagram, we write the probabilities at the end. So I'm just going to do it. I'm going to use my colors again. You don't have to do it in different colors. So probability of red, red. That's red, blue, blue, red, and blue, blue. And where I'm getting that, sorry, refocus that, that's fine. Okay, so where I'm getting that is red, 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 blue, blue, red, blue, blue, following the branches. Again, we would have done this in 3rd year, so I'm not dwelling on it too much. And the way we do this, the probability of red, red is this and this. We need this and this to happen. So we do 3 over 5 times by 2 over 5, which is 6 over 25. The probability of red, blue is 3 over... making a mistake again. 3 over 7. So it's 6 over 35. 6 over 35. The probability of red, blue is 3 over 7 times by 3 over 5. So we're going this route. So that's 9 over 35. The probability of blue-red is 4 out of 7 times 2 out of 5 equals 8 out of 35. And the final one for probability blue-blue is 4 out of 7 times 3 out of 5, and that is 12 out of 35. And I'd never try and simplify these because they're easier to add at the end. Okay, so I just leave them as fractions. I don't think you could have simplified any of those anyway, but if they do simplify, I just leave them like that. And now you've got the probabilities of all those 4 different outcomes. Probability red, 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 blue, blue, red, blue, blue. And the reason we do this then, because they could ask any number of questions, and the only question they ask is, I work out the probability that they'll both be the same colour. So probability, same colour. There's 2 occasions where it's the same colour, where they're both red, 6 out of 35, or if they're both blue, 12 out of 35, and we just add those 2 because we want this or this to happen. When we want both of them to happen, we multiply it, and when we're looking down here, we add. So it's 6 out of 35 plus 12 is 18 out of 35. If they'd asked us at least one blue, you could have added these 3 together, or just one taking away this, because all of these will add up to 35 out of 35. It's a way of checking your answer. So they could ask any number of questions. Okay, we'll quickly go on to the second one. It's over here. Okay, this is the second example where there's 3 things occurring, and it says 3 diagrams were events without replacement. So again, subtlety. Now I've changed it from the thing, I've done 5 red and 7 green as opposed to 5 yellow and 7 green, because our school hasn't invested in yellow markers, so I've only got the red ones. Okay, so beta is removed and not replaced. So I'll read it out, and I've just taken the shorthand here. The box contains 12 beads, 5 yellow and the rest green. So I'll say 5 red and the rest green, 7 green. A bead is removed from the box and its colour noted. It's not returned to the box, so it's taken out. A second selection is then made. It's the same box, and it's not put back in, and then a third. So there's going to be 3 things. So I'm going to title the first one in the first selection. So the first selection, there are 2 outcomes. There are red, and there is green. Okay, and before I put all the probabilities in, I'm going to show in the second selection there are also 2 outcomes. And again, 1 red and 1 green. And then in the third selection, okay, I'm going to run out of this. We have, for each of them we have 2 things, and we have obviously red, 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 and green, 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 and green. Okay, now I've drawn out first of all because I want us to now concentrate on the actual probabilities. The first one's handy enough. It says the probability of red is 5 out of 12, and green is 7 out of 12. Now here where it's not as easy, it's not the same as saying 5 out of 12, 7 out of 12. Because if we follow this path, what have we chosen in the first selection if we follow this path? We've chosen red. So the probability of my second go of choosing red is only 4. There's only 4 reds left in the packet, or in the box. And there's only 11 in total, because 1 has been removed and taken out. And the green there's still 7 greens, but there's only 11 in total because a red has been chosen. That's if we follow this path. If we follow this path, a green has been chosen in the first one. So there's still the same amount of original reds, 5, but again 1 has been removed, but there's actually 1 less. There's only 6 greens, 6 out of 11. And that's where they're getting that. And then the final one, you just have to be careful. If we follow the top path, 2 reds have been chosen. So in this case there would only be 3 reds left, and there would only be 10 counters left. Whereas if we follow this path, none of the greens have been chosen yet. So there is still 7 greens left, and there is only 10 left. That's where you get the 7 out of 10. Now if you got to that stage, it would be obviously way more likely to get the green in the third go because there's only 3 left. Now, be careful, be very careful with these, because you're following it carefully. You can still make mistakes. So if you're rushing through it, you will definitely make mistakes. If we follow this path, a red has been chosen, and then in the second one a green has been chosen. So we know there's only going to be 10 left. How many reds will be left? There'll be 4, because we've only chosen one red. And the same way here, there'll be 6 out of 11 greens. 6 out of 11 greens. Or 6 out of 10 greens even. There's only 10 left. And now, I know I'm squeezing this in. If we choose this path, 1 green and 1 red, this is also going to be 1 red and 1 green taken out. So we're going to have the same as the last time. 4 out of 10 here. This one's with this and this one's with this. And then in the bottom, we're going to have 6 out of 10 for green, because one of the greens is gone and one of the reds. And in the bottom one, 2 greens have gone. So none of the reds have been chosen going into the third attempt. So there'd still be all 5 of them. 5 out of 10, or 1/2, but leave it as 5 out of 10. And then the last one, green, 2 greens have been chosen, so there's only 5 greens left out of 10. So there's actually an equal opportunity at the end for those two. Now you'll see in the example, they only pick out certain ones to look for, but I'm going to do the whole thing. Okay, you can fast forward if you know what's coming. So probability of, I'm going to do probability of, I'll use my color coded. Okay, probability, if we follow this top path, red, red, red. If we follow the second path, red, red, green. If we follow the third path up there, it's going to be red, green, red. If we follow this, it's going to be red, and then you can see green, green. Just make sure you can get those. If we follow the bottom path, obviously the first one is going to be a green, and then it's going to be red, red. And if we follow the second path, it's going to be green, red, green. So I'll put that, green, red, green. And if you follow this third path, or this second last path, it's green, green, red. And then the last path is green, green, green. And you can work out the probabilities of all of those if you want. Probability of red, red, red is 5 over 12 plus, times 4 over 11 times 3 over 10 is equal to, and then again you'd have all these 5 by 4, 5 by 4 by 3, 60 over 12 by 11 by 10 equals 1320. And you would do the same for this one. So this one would be 5 over 12 times 4 over 11 times 7 out of 10. Okay, and you'd complete that. I'm not going to go through the whole thing. I'm sure you can all do that. Now, what they ask, draw a T-diagram to outline the situation. Find the probability of exactly 2 green beads. So exactly 2 green beads. I'm only going to fill out the ones that have 2 green beads. You could do it for all of them depending on the questions you're asked, but the 2 that have the green beads. So this one is probability, it's 5 over 12 times 7 over 11 times 6 over 10. And when you multiply that out, you get something over 1320, and that simplifies down to 7 over 44. The calculator simplified that down for you. You could leave it as that as well. The other time where there's 2 greens is this one here. So this is green, red, green. So it's 7 out of 12 times by 5 out of 11 times by 6 out of 10. That's the same as the other one. 7 out of 44. The numbers in the top are the same, the numbers in the bottom are the same. And the only other time there's 2 greens is this one here. So it's 7 out of 12 times 6 out of 11 times 5 out of 10. And that's the same as well. So the question asked the probability of exactly 2 greens is equal to 7 over 44 plus 7 over 44 plus 7 over 44 is 21 out of 44, and that's where they get that from. But again, if you've laid all of this out like this, you could answer any number. Or go back to the bit, sorry, that if you're unsure. Any questions, please do ask. We're going to try and go through probability fairly quickly.